Hello my dear students, this is Physics Balaji. Today let us discuss a problem based on conservation of linear momentum and conservation of mechanical energy. Here, a ball of mass m is released from point A inside a smooth wedge of mass small m as shown in the figure. It was the wedge. In this, a ball of mass small m is released. Even wedge mass also m, ball mass also m. From here, this ball will come like this. As the ball was sliding from A to B, so what is the velocity of the wedge they was asking? With respect to wedge frame, this ball was sliding like this with a velocity u relative. Here u relative means velocity of the ball with respect to wedge. Here this angle we know, this we know, then this angle will be 45. Along x-axis, we can resolve u relative cos 45 and along y-axis, u relative sin 45. So velocity of the wedge formula V equal to minus m u relative by m plus m. It was the formula where m is the mass of the body which was sliding. It is the relative velocity with respect to wedge. Capital M mass of the wedge, mass of the block. Use this formula here. Here mass of the block is m only. Relative velocity along x-axis u relative cos 45. Both are having same mass, so m plus m. With this velocity, wedge will slip back when the ball reaches B. We know that u relative means velocity of the ball with respect to wedge. Velocity of the ball minus velocity of the wedge. Along x-axis, relative velocity was u relative cos 45. So relative velocity along x-axis we know. Velocity of the ball x-axis. So velocity of the wedge along x-axis we got minus u relative 2 by 2 root 2. Apply here. From this we got velocity of the ball along x-axis. Similarly, relative velocity of the ball along y-axis was u relative sin 45. So ball velocity along y-axis, wedge velocity along y-axis 0, we know this. From this you got u by. Now ball velocity will be u xi, downward direction u by j cap. From this I can find magnitude of ball velocity like this. U x we know here. U y we know here. Substitute, we got ball velocity like this. Now everything is smooth. Let us apply the law of conservation of mechanical energy. Energy at A equal to energy at B. So let us take it as a reference level. On this reference level, potential energy at A is 0. Initial rest kinetic energy is 0. As it reaches B, potential energy will be from here to here height. This was R, it is 45. This will be R cos 45. Cos 45 equal to adjacent side by hypotenuse R. Now this adjacent side value we will get R cos 45. This value was R cos 45. So below the reference level, so minus mg, h value, this value was R cos 45. When the ball reaches here, velocity of the ball was ub, kinetic energy formula half m ub square. At that time, wedge velocity was v, half m v square. Substitute ball velocity and substitute wedge velocity. On solving, we got the equation like this. We know the relation between wedge velocity and relative velocity like this. In place of u relative, substitute this one and solve to find velocity of the wedge when the ball reaches B. Thank you.